Okay, hi everyone. In this video, we're going to go ahead and talk about something called solubility rules. So for a quick review, solubility is the ability for something to dissolve in water. And if it is soluble, we can say that it dissolves in water and it has the label AQ or aqueous. If it's not able to dissolve in water, we call it a solid, okay? Or in some cases, a precipitate. So let's get to that. So in double displacement reactions, we usually have two different solutions that we mix together. And we use solutions because when compounds are dissolved in water, they react faster than if we have just two solids that we mix together. So when we combine those two reactants in the double displacement reaction, we have two main possibilities that can happen. The first one is that nothing happens at all. And we call this an inert reaction, meaning that nothing changes. It all just stays the same. The other possibility is we have those two things react with each other. And when this happens, we can either get bubbles forming, which is the formation of a gas, or we can get a precipitate that forms. And this is a solid that forms from those two different liquids. Now, it's not a whole big clump of solid at the bottom of your beaker. It's usually tiny little particles that are suspended in the solution. So the precipitate will maybe look a little chunky or be opaque. You won't be able to see through that solution anymore. And we can determine whether or not a precipitate will form by using solubility rules. Now, there are specific rules for solubility. I like to simplify it a little bit, so that's what we're going to go through first. So my first rule that I tend to think of is that compounds containing the following species are always soluble. So if you have a nitrate, acetate, ammonium, or any alkali metal. Okay, remember hydrogen, even though it's in group 1, is not an alkali metal because it's a nonmetal. So if it has one of those things, then that compound will be soluble and able to dissolve in water. Okay, so the second rule states that compounds containing the following species are generally insoluble, meaning that they won't dissolve in water, or that if they're a product, they will form a precipitate. So anything with carbonate, hydroxide, phosphate, or sulfide, those things tend to be insoluble. One thing I do want to note is that Rule 1 supersedes Rule 2, meaning if you have something in it from Rule 1, it's going to be soluble, even if you have one of these Rule 2 elements. So for example, sodium hydroxide, okay, has sodium, which is an alkali metal, and hydroxide, which is one of those Rule 2 compounds. So even though it has both of those, it's still going to be soluble because the alkali metal from Rule 1 supersedes or is more important than Rule 2. Okay, so the other way that I like to think about this instead of having that big list of elements is nah, cops. So maybe a robber or someone like that would say it. I know it's a little ridiculous, but this gives you a little mnemonic to help remember. So Na stands for nitrates, acetates, ammonium, and alkali metals. So those 4 things. And then COPS stands for carbonates, hydroxides. I go for the O there, so it's a little off, but it's okay. So carbonates, hydroxides, phosphates, and sulfides. Okay, so Na COPS is what I want you to remember for solubility rules. So here I have a list of different examples. I want you to go ahead and try to figure out whether these are soluble or insoluble without using the chart in your notes. So think about the Na COPS rule. If it has something from Na, nitrate, acetate, ammonium, or alkali metals, then it's going to be soluble. If it has one of those COPS and it doesn't have anything from the Na, then it's going to be insoluble. So go ahead, try and figure out these solubilities. Okay, so let's go ahead and talk through these. So the first one, calcium carbonate. Well, it doesn't have a Na in it, but it does have carbonate, which is part of COPS. So that is insoluble. Next one, copper sulfide. Again, we do not have any Na elements. So we look at the S for the sulfide, which makes it insoluble. The next one, ammonium hydroxide. So we have a Rule 1, which is our ammonium, and Rule 2, which is our hydroxide. But Rule 1 is more important, so that will be soluble. The next one, magnesium nitrate. Okay, the nitrate is the N of our Na, so it is soluble. For the magnesium hydroxide, okay, we have a hydroxide, so one of those COPS elements, so it's insoluble. And then lithium sulfate. Okay, so lithium is an alkali metal, so it is a soluble compound. Okay, so in your notes, you also have a table that looks like this. It is obviously more detailed than our NA COPS, but you can remember NA COPS a lot easier than you can remember this specific table. So keep in mind this is here. We'll give you a little bit more details because sometimes you get things that are kind of soluble, but not really. That would be the slightly soluble yellow compounds. But if you look at those mixtures, you'll see that most of the time that NA COPS will give you the right answer about 95% of the time, okay? So that's just something to help you out. Okay, so we can use solubility rules to determine the phase labels for double displacement reactions. So if a product is soluble, that means it's going to stay in the solution, it's going to stay dissolved in the water. So it will be aqueous, and we're going to use the symbol AQ. If the product is insoluble, that means a precipitate will form. So we're going to use the phase label S for solid. So let's go ahead and try this out with an example. Okay, so let's go ahead and work through an example. So this first one, we have silver nitrate and potassium chromate, and they're reacting to give us potassium nitrate and silver chromate. Okay, so we want to think about the phase labels, and then we need to balance this. So we're told that both solutions are initially aqueous. We just need to figure out the product, and one of them is going to be a precipitate, and one of them will not be. So I want to think about my Na and my COPS rules. Okay, so Na, all nitrates, alkali metals, ammonium, and acetates are soluble. So if I look here, I have potassium, which is an alkali metal, and then I have my nitrate. So this one has two things that are soluble. So this one is definitely going to be our aqueous compound, which means that our solid is going to be our silver chromate. Okay, and that's because we have a precipitate reaction. One of those things has to be a solid. Since this one must be aqueous by process of elimination, that leaves the silver chromate as the solid. Okay, so let's go ahead and balance this. Now remember, you have two options. You can either balance each atom individually, or you can group together your polyatomic ions, whatever you prefer to do. So I'm just going ahead and writing my atom inventory. So to start on my reactant side, I have one silver atom, one nitrate, two potassium, and one chromate. On my product side, I have two silver, one nitrate, one potassium, and one chromate. Okay, so I want to start by balancing my silver. So I'm going to go ahead and put a 2 in front of my silver nitrate on my reactant side, and that packs both my silver and my nitrate. So I'm going to go ahead and update those. So now I need to go ahead and balance out my nitrate. So if I have 2 on my reactant side, I need 2 on my product side. So I'm going to go ahead and put a 2 in front of my potassium nitrate, which balances both the nitrate and the potassium. So that gives me my balanced chemical equation. Okay, so now I have 2 different problems I want you to go ahead and try on your own. Okay, so now I have 2 different examples I want you to try on your own. There is a correction. There's a little typo in your notes. So for the first compound for the products, the ammonium sulfate, we need a parentheses and a 2 around the ammonium. So make sure you fix that in your notes. It will be important for balancing. And then I just want to point out for that last reaction there, the iron sulfate with the barium iodide, none of those compounds are part of the Na COPS rule. So I want you to go ahead and use that table in your notes to figure out the solubility of the 2 products. So go ahead, pause the video, figure out the solubility rules, and balance these 2 reactions, and then come back. Okay, so for our 2 U-try problems, for the first one, the ammonium sulfate, the ammonium, of course, is part of rule 1, so that is our aqueous product. The cobalt chloride is our solid that forms, okay, just by process of elimination. So now if we balance this reaction out, it's really, really simple. We just need a 2 in front of the ammonium chloride reactant. And then for our second problem, we need to go ahead and figure out the solubilities. If you look on that solubility chart that you have, the iron iodide product, that one is going to be aqueous, and the barium sulfate, that is going to be the solid that forms. Okay, so for balancing this, We have 2 iron on the reactant side. We need 2 on the product side. So I put a coefficient of 2 in front of the iron oxide. From there, we need to balance out the iodine. So if we have 6 on the reactant side, 6 on the product side, we need 6 on the reactant side as well. So we put a 3 in front of the barium iodide. And then finally, to finish up, a 3 in front of the barium sulfate product. So I hope that helps. If you have any questions on this, please let me know. Have a great day, everyone. Bye.